Hello, this is another episode of Setting Up Azure Resources. I'm Richard Knuckles, your host. When we left off last time, we had just set up our Data Lake Analytics service in Azure, and we'd run our first job. So in this episode, we're going to be looking at what happens when you've got multiple jobs in your history and you're running jobs with multiple AUs. Here in the job management blade, which you can access on the left-hand nav in your Data Lake Analytics service in the Azure portal. As you can see, I've run several U-SQL jobs here in the last day, a couple yesterday and a couple today. While we're on the subject of the job management panel, you can modify the number of days to keep your job history in the limits and policy blade in your Data Lake Analytics service. By default, you get 30 days. This data is stored in the Data Lake storage. That's the primary for the Data Lake Analytics service. You can increase this beyond 30 days. You'll just take up more storage space in your storage account or your Data Lake storage Gen 1. So to look at what we have in job management, you can see multiple fields which give you details on the job history for the jobs that you've run. I'm an administrator on this service, so I get to see job listings from all of the users who submit jobs to this. If you're just a reader or a contributor, someone who has one of the roles other than administrator or owner, then you just see the jobs that you've run. So you can see in the first column here, we have the status of the jobs. The first one we ran yesterday failed, and then we corrected the error and ran the job a second time. Then we have 3 jobs here, all of which succeeded. You have the job name, and in the first case here, we use the same name for 2 different jobs, so it's a little bit hard to differentiate the two. But because you can see the author of the job, I can tell that both of these jobs were jobs that I created and ran myself. Because they have the same name, my rule of thumb is these jobs were meant to do the same thing or use the same script. In the case of these 3, these are examples showing the use of 1, 2, and 3 AUs. So in this case, the job name comes in handy trying to figure out what this job was covering. In the third column here, you can see the number of AUs that were used. AU is analytical unit. It's a measurement of how many parallel nodes that are being used for this particular job. Each of these AUs represents a node in a cluster for the Data Lake Analytics service. In the case of the Access 1 AU job, we ran 1 AU. In the Access 2 AU job, we ran 2 AUs, and in the Access 3 AU job, we ran 3 AUs. These are always going to be U-SQL type, and you can tell from the duration here that this job took advantage of parallelization. With a single AU, it took over 4 minutes. With 2 AUs, it took 3 minutes. Not half, as you might expect, but a reduction. And then with 3 AUs, down to just over 2 minutes. So we can click on the name of the job to jump straight to the job history details blade. When you're looking at a running job, you can actually see the current progress. Since this one has completed successfully, where progress is at 100, you can tell the overall cost for running the job, its job efficiency, and how long the job took to run overall. In the bottom here, we can see this took 40 seconds to prep this script. It executed for 3 minutes and 19 seconds overall. So we were charged 12 cents for 1 AU for 3 minutes and 19 seconds of running. You can see here in the script tab, this is the script that was executed. It has the familiar setup, a variable declaration defining the files to use, an extractor statement here giving us a row set called players, select statement here giving us a second row set using the players row set from before. This one includes a variable declaration defining the path to the output file, and then an outputter statement using the outputter and the daily ag row set. In this case, I loaded up multiple documents for this job so that I could demonstrate the use of the wildcard here in the script. These files were called access_00 through 06, and using the wildcard, all 7 of these files were imported. Finally, you can take a look at the AU analysis here. You can see that this one was run with a single AU. So in this case, you can see that we ran this job 2 AUs. That's the blue line here. The red line here is the actual utilization of the AUs within the script. See that for most of the script execution time, we were running with all of the AUs, but for the portion of the time, we only used a single AU. This means that this job was not 100% efficient because it couldn't use all of the allocated AUs for all of the time. And this is quite common. In fact, it's going to happen with most likely all of your scripts. Unless you're using a single AU for an extended period of time with a large amount of data, you're going to fall well short of 100% efficiency when running your jobs. As you can see, this is similar to the 2AU in that we have a period where we are reading into the cluster and on the nodes. Then we have a period of calculations where we're only using a single node to do the calculations on the data. Then we have another period where we are writing the output file out to our data lake store. And in this case, we're using 2 AUs to do that writing. But after about halfway through the job, we no longer are running with all of our 3 AUs, and we no longer get back to using all those 3 AUs. So in this case, we are likely running fairly inefficiently and throwing away a bit of money in order to get a bit of speed, a bit of shortening in the time it takes to run this job. In this case, you can see the efficiency was approximately 54%, calculated after the end of the run. We ran 7 files of approximately 377 meg each. That gives us approximately 4 gigs total data read into our job, into our cluster. See, at 3 AUs, we ran at 54% with a minute and 38 seconds of runtime. We can click on these AU calculations here to see what we could have run. So here, the balanced level was 2 AUs. And we can see here highlighted the green level. We would have run up to here in our data read, so taking a fair amount longer, about 50% longer, to read in our data, and then taking some time at 1 AU to do our calculations. This is basically the same amount of time that we took when running at 3 AUs, and then a similar amount of time running at 2 AUs to write the file out. See, this is calculating an efficiency of 76%. Fast is the 3 AUs that we actually used. You can see the actual efficiency and the calculated efficiency normally do not sync up, but at least the runtime is generally pretty close. So you can add in your own custom level of AUs to get a calculation of what this job would look like when you run it with a higher number of AUs. In this case, we're looking at 6 AUs here in our purple line. We only ever use 3 AUs during load, and then we're down to 2 and 1 AUs for feeding calculations and output. So 6 AUs would be over allocation for this and wasted expense with no benefit to us for our running of this job. One of the hard parts about using Data Lake Analytics for your first job is knowing how many AUs to choose. This is a job graph. It shows you graphically what the job was doing at each of its steps. It does include some good calculations to help you understand where your AUs are being used, what processes are running through, and how the compiler is breaking down and compiling your script into executables that run in the cluster. In this case, you can see we had 7 files, 377 meg for the first file, access_00. Overall, the extract portion of the script read 4 gigs in, and then from the row set that was generated in the extract, we had an aggregate that read 2.9 megs of data out of the 4.09 gigabytes of data that was read in. This is because we didn't use all of the fields and didn't write out all of the fields to subsequent steps, so we only needed to read portions of the data in to this aggregation step. We ran 1 second here, 0 seconds here at the aggregate step at 1 vertex, and then we wrote out 723 kilobytes at the end. You might be interested to know what a vertex is. This is a subunit of the AU. Each AU can have up to 4 vertexes running. Vertexes are chunks of files that can be run in parallel, or they are chunks of computational elements that can be run in parallel. Because of the way this query was structured, all of the data needed to be run through a single aggregate, so there was only 1 vertex that could be used there. A vertex is equivalent to about 250 megs of data being read in at any particular time. In this case, because we had multiple files and we had multiple AUs, we could run multiple reads in parallel. So if you want, you can take a look at the data files that are being read in. Because this is a text file, we can pull it up and read it here in the file preview. And under the output section here, you can see the daily access count, which was the output of the query. All right, that is job management. If you want to learn more about Data Lake Analytics, we've got a few different videos on this service here in the channel. One last thing we'll go over before we end. The Data Explorer allows you to add data sources and view the files that are in your data sources. In this case, we're looking at a data lake store, which is a hierarchical store, and we can see in the demo folder here the access files that we were looking at earlier, and in our curated file folders outputs, daily access count from today, daily value ag from yesterday. All right, in the next episode, We'll be talking about the catalog and setting up data objects in the catalog for reuse in your U-SQL scripts. Goodbye.
Click subscribe to see more videos like this. If you liked this video, hit the like button. Leave a comment in the section below to let me know what videos you'd like to see in the future.